Okay, hi everyone. This is Soumya Paul, a mentor at CodeCardos and a software developer at Amazon. And welcome to day 21 of our DSA series. Now, in the previous videos, which I guess we covered long back because unfortunately we were covering some other videos on our channel, and this series took a little bit of a break. So in the previous videos, we were talking about strings, how strings are stored, different things about strings, its utility functions, etc. Now, finally with that we have covered some basics of Java. Finally, from the 21st video, we will be covering recursion. And with recursion, we will actually be starting the start of our DSA journey. Okay, so we will be starting with this topic called as recursion. Now, trust me, I know that recursion is very, very difficult. I know a lot of you will find recursion difficult, but recursion is literally the most important topic in data structures. In the entire DSA, recursion is literally the most important topic. Why? Because if you just know recursion, you will not only be able to solve questions related to recursion, but there are many other topics: dynamic programming, backtracking, binary trees, binary search trees, graphs. In all these five topics, 95% of the questions are solved using recursion. Dynamic programming and backtracking are kind of extensions of recursion, but the other topics, binary trees, binary search trees, graphs, in those three topics as well, 90 to 95% of the questions are solved using recursion only. And even in other linear data structure topics as well, suppose arrays, strings, linked lists, stacks, queues, you will be having many questions which will need recursion to solve. So, this is one topic which literally is the most important one, and also since it is very difficult, we will be spending a good amount of time here. Okay, so now what is recursion? Recursion is a way, it is nothing, a way of coding where you ask the computer, where you ask the computer to solve the computer to solve or maybe in a way I can say, maybe not in this way, I can write it in a better way. Maybe I can say is a way of coding where you divide a big problem, divide a very big problem into two parts. Okay. Now what we do is, suppose you have this big problem to solve. You have this big problem to solve. Now, you want to solve it using recursion, let's say. So what you will do is, you will divide this big problem into two halves. But you may think that you should divide this problem into two equal halves, but no, that is not what you will be doing. You will be dividing this problem in such a way that it is not equal. You will have a very tiny part of the problem. This can be called as, say, smaller problem. And you'll have a much bigger part of the problem, which can be called as the bigger problem. Now, you will solve this smaller part of the problem. Suppose you solved it, and the answer of this is smaller answer. And you will ask recursion to solve this bigger problem. Okay, you will ask recursion to solve this bigger problem. And let's say this bigger problem's answer is bigger answer. Now, when I say we will ask recursion to solve, what do I even mean by recursion? In a way, asking recursion to solve means asking recursion to solve this means that you pass bigger problem to the same function. Okay, to the same function. This is what you do. So in a way, recursion basically means multiple function calls, or I can also say calling the same function inside another. Okay, calling the same function inside it, calling the same function inside itself. Okay. Calling the same function inside itself. So, but don't worry, if you're not able to understand these two lines, don't worry. When we write the code, you will understand. Right now, that understand just this much, that the gist of recursion is that you have a big problem, you have a total problem. Suppose this is your total problem. You divide this total problem into two parts. One is the smaller problem, another is the bigger problem. And then you solve smaller problem. You will be solving this part. Okay. And then you ask recursion to solve this part. Suppose you solved it and you stored it in smaller answer. Then you will solve for recursion and it will store it in bigger answer. Now, what you have to do is, you have to combine them. Smaller answer plus bigger answer, you will get the total answer. Or you can also say final answer. This is what your answer will be. This is what you have to return. Okay. This is what the gist of recursion is. Now, let's do it in practice. Suppose, let us try to solve a problem. Suppose I have to solve a code where I have to return, I have to write a function which will take x, which will take n, and it will return the answer of x power n. Okay. So, let me bring up an online code editor. And let's say I have a function here, power, and it receives x, receives n. Now I want to return x power n. Now I know all of you might be thinking, hey, that's very simple. I can simply say return math.pow x comma n. Okay. But right now I want to solve this question using recursion. So we will not use the inbuilt utility function and we will solve it using recursion. So now how can we solve it using recursion? Let's see. So now you have this problem to solve. You have this big problem to solve, that, oh man, I have to solve x power n. Very, very big problem. Now again, we'll do the same thing. We'll try to divide it in a way such that it will be divided into smaller problem and bigger problem. So yes, what does x power n means? X power n means x getting multiplied n times. So this is nothing but x getting multiplied n times, isn't it? X getting multiplied n times. Okay. X getting multiplied n times. So now if I have to divide this problem, how will I divide it? I can divide it in such a way that I will say, let me divide it in this way. Okay. This is my smaller problem and this is my bigger problem. So my smaller problem is what? Just 1x, x power 1. And bigger problem is what? Bigger problem is x power n minus 1. Because now n minus 1 x's are left. Isn't it? So what I will do is, I will divide it in this manner. So that is what we'll do in the code as well. I will say int smaller problem is equal to x power 1. Okay. So I can just say math.pow x comma 1. Okay. And math.pow returns a or x power 1 is simply just x, isn't it? I can just say it as x, isn't it? You see, this is just one x, just one little x. So now, if this is smaller problem, what will be the smaller answer? Smaller answer will be what? Again, x only, isn't it? X is the problem. I have to raise it by 1. X is the answer. Now, what is my bigger problem? Int bigger problem is what? Int bigger problem is what? X power n minus 1. So if I have to solve for bigger problem, I will say my bigger problem is x power n minus 1. Okay. And here also I can just comment it out. I can just say smaller problem is x power 1. Okay. So since my bigger problem is x power n minus 1, I will say bigger answer is power of x comma n minus 1. That's it. Okay, that's it. So this is what I have solved. This is what I have solved And this is what recursion is solving. This is what recursion is solving. Now, since I have got smaller answer and bigger answer, I need to combine them. Now, since I've got smaller answer and bigger answer, I need to combine them to get the final answer. So I'll say final answer is what? If I have x and if I have x power n minus 1, how can I get x power n? By simply multiplying them, isn't it? So here, see, the smaller problem is always what I'll solve, Okay. This bigger problem is what always recursion will solve. Okay. And here, so I have solved the answer as x for smaller problem. Recursion has given me answer x power n minus 1. Now you might be thinking, how is recursion giving the answer? How is recursion giving the answer? That is something we will see when we dry run the code. But till now, for now, just have absolutely blind faith in recursion that yes, recursion will give you the answer. This function call will give you magically x power n minus 1. It will give you x power n minus 1 and then you can store it in bigger answer. How does recursion give? Don't worry. Have blind faith in recursion and believe that recursion will return you x power n minus 1. You have solved for x power 1. Recursion is solving for x power n minus 1. Now all you have to do is just combine them, just merge them. Okay. How do I merge them? Just multiply them. If I multiply x power 1 with x power n minus 1, I get x power n, which is exactly what I want. So here I can simply say smaller answer into bigger answer. Okay. And then I'll return it, final answer. Okay. So this is how you are solving recursion. Now suppose here in system.out.println, if I say power, if I pass 2, 5, then what does it become? It becomes, okay, so there are some issues. Let me fix them quickly. So what does it say? Oh, I haven't written the data types. Nothing to worry about. Okay, so yes, now we are getting this issue. Why? This is called as stack overflow because there are infinite number of function calls. So there is one more step in the recursion code that we have to write a base case. Okay, so one more step is we have to write a base case. Okay, now what is a base case? What is a base case? A base case is nothing but find the smallest problem that you can solve by yourself. Find the smallest problem that you can solve by yourself. And return the answer for it. Okay, return the answer for it. Now this is exactly same as finding out smaller problem. The only difference is that in smaller problem you store it in an answer. You stored the answer in a variable called smaller answer. But in the base case, you will simply return it. So here in the base case, you can write something like if n is 1. If n is 1, you have to solve x power 1, which is a very, 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 very simple problem. And you can very easily do it by yourself. What will be the answer? Answer is x. But here you were storing it in a variable. Now you will simply return it. So you will simply say x. That's it, done. Now if you run this code, it should work perfectly fine. 32. 2 power 5 is 32. Okay, suppose I say 3 power 5. It's 243. Okay, so this is how you will write recursive algorithms. But don't worry if you still have not understood, because we will be doing a lot more problems and figuring out how to actually dissect the problem, how to actually divide the problem into two parts, smaller problem and bigger problem. Okay, for now I hope you have understood the gist of recursion. And if you want to learn these concepts and in a much more in-depth manner, and you want to prepare to apply to join top-notch product-based companies like Mang companies or similar Mang companies, and if you want to prepare directly from Mang developers like me, then do join Code Kurdos, and I'll see you all in the next video.